Alright, well, we're going to talk about, in this module, voltage dividers, voltage drop, and Kirchhoff's voltage laws. Basically, how we can look at a circuit and measure or mathematically determine what a voltage is at any particular point. So for that, let's get ourselves a sample circuit so that we can talk about this. And I've kind of drawn a bad circuit here, but that's okay. We can make the best of things. Alright, so we have an R1, an R2, and a V. V1. And let's call V1, let's use 12 volts. R1, how about 1 kilo ohm, and R2 equals 2 kilo ohms. Now, up to this point, when we've done series circuits, all we've done is we've added up R1 and R2, and then to find the current, we just divide V1 by R total. And so we can do that. R total is just 1,000 plus 2,000 is 3,000 ohms, and V1 is just 12 volts. So I, for this circuit, is just 12 divided by 3,000. And that equals 0.004 amps. That's 4 milliamps. Okay? Well, now we can find out what the voltage drop across each resistor is. And what we mean by that is that as this, right here we have 12 volts. Here we have 0 volts. And as the current goes along here, less and less voltage is in that circuit. In fact, if we strung together a whole string of resistors, if here we had 12 volts and here we have 0 volts, after every resistance there will be a change in voltage, and it will get less and less until it gets down to 0. It starts out at 12, and now it's 12, something less than 12, and then something even less than that, and something even less than that, until you get to 0. And if we put values on these R1 and R2 and R3, we can actually tell you what the voltage is going to be right here. It's just going to be 12 minus the current in this circuit, right? There's only one current. It's just a series circuit. The current in this circuit times R1. And that is what this voltage right there would be. It's 12 minus whatever volts got dropped across here. And that's what we mean by a voltage drop, is that because there's current flowing across this resistor, we have a voltage. We have a potential difference between this point and this point. So up here on this circuit, this is our 1,000 ohm resistor up here, we can calculate out what the voltage drop will be because we know what the current is. We said it's 4 milliamps, 1 kilo ohm. So let's forget this for now and look at this top circuit for a second. So let's calculate what the voltage drop would be, and then we can find out what the voltage right here would be. So we have the current I times R1 gives us some sort of voltage, V equals IR, and we know what all those values are, so we can plug in 4 milliamps times 1,000 ohms, and that's going to equal 4 volts. That's the voltage drop. So if we want to find the voltage at this point in between these two resistors, we call this a node, and we'll call it node A. So V at A, we will say that's equal to 12 volts minus the voltage drop, R1 times I. And so that VA equals 8. Sorry, VA equals 8. Okay, so we just had the voltage drop, which was 4 volts, and we plug it into our equation to find VA. We have 12 volts minus this, what we just calculated at 4 volts, and so the remaining is just 8 volts. we can do the same thing across R2, as we can say how much voltage drop is across that. Well, we can calculate that out. So let's say how much volts across R2. So we'll say the voltage across R2. And basically it's just going to be I times 2000. And so that's R2. So it's 4 milliamps times 2000, and that's going to equal 8 volts. 4 times 2 is 8. And that's exactly what we suspect, because we already said the voltage at node A, we calculated that up to be 8, and here it is 8. So that's simply it. Now how does that help us with the voltage divider rule? That's voltage drop is what we just talked about. And in fact, if we look at this, you can see that the voltage drops equal the source of voltage, and that's Kirchhoff's voltage law, basically. Because there's 4 volts here, 8 volts dropped here, that equals 12 volts, and that's how much voltage there actually was, and so that's Kirchhoff's voltage law. It's intuitive and makes sense, and so we should be able to understand that to get back to 0 volts, starting at 12, we had to lose all 12 of those volts. Alright, now, the voltage divider rule is real simple. Is basically what we're what we're trying to find here is what is the voltage across R2 or R anything, and what we want to do is we want to find it as a fraction of the total voltage. So for instance, in our last circuit, R2 and R1 and our 12 volts, we wanted to find out what the ratio here is, and so we knew that, we found that it's 8 over 12. 8 over 12, right? The total voltage times VR2. But how about if we just plugged in I times R for those values? Well, we put in I times R2 over I times R1 plus I times R2. This is the total voltage. This voltage drop and this voltage drop is just equal right here, and this 8 is just I times R2. So, with that said, we can do a little bit of algebra. We can bring this I times R2 over here, and we can factor out an I out of both of those, so we leave it as I times R1 plus R2, and then we can get rid of these I's. They cancel out. I over I is just 1. So I hope you see how we did that. We started out here, we plugged in for VR2, I times R2, and then for V total, I times R2 plus I times R1. Now we just factored out this I, and we're left with R1, R2 over R2 over R1 plus R2, and these I's are going to cancel out. We can get rid of them because they just go to 1. So that's like saying I over I times R2, R1 plus R2, and that whole thing is just 1. So it's just equal to R2 over R1 plus R2. So now we have a formula to tell us what the voltage is across R2 without ever finding out what the current is. And that's really helpful if we have the black box scenario where you don't know too much about it. You just know, there's something in here. And maybe you're putting in 12 volts and you want out 6 volts. Well, you know that you can design this circuit then inside of here to do that. Basically, we want something that's going to give us 6 over 12, or that 6 over 12 is of course 1/2. And so we need an equation that says, let's call this R2 and this R1. We need an equation that says R2 over R1 plus R2 is equal to 1/2. And that can simply be done by saying, let's say this is R2 is equal to 1. Let's let R2 equal 1, and R1 equal 1. Now on top you have 1, let's use kilo ohm. So R2, oh, well, I don't need to rewrite this. We have R2, R1, and R2, and we can plug these things back in, and we have 1 kilo ohm over 1 kilo ohm plus 1 kilo ohm, and that's just equal to 1 over 2 kilo ohms. And that stuff goes away, it's just 1/2. It's just 1/2. And so you can design a circuit to get the needed output given an input for this voltage. Now this is true for any voltage. If you want 20 volts in, if you have 20 volts in, you only want 10 out, it's the same rule. And that's a voltage divider circuit.